If you clicked on this video, you are probably a supply chain professional working in manufacturing or logistics, and you have, from time to design layouts of factories or warehouses. And you are looking for an efficient way to do this. You don't have a lot of time and you want to be precise. And this is exactly what you will find in this video. My name is Samir. I'm supply chain engineer. I've been doing that for the last 10 years. And sometimes I have to design layouts of warehouses mainly, and sometimes factories, for two reasons. The first one is the customer wants to move to a new location. So they got a proposal from the real estate broker and they want to know if everything fits in the new location. Or sometimes they just want to optimize their current layout. And for that, I have two methods. The first method is this one, the fancy one using SketchUp. You have very nice 3D visuals. It's very good if you want to prepare a commercial presentation, sell the solution to external consultants or to the top management. But it takes a lot of time. And I have another method using Excel that is most efficient in terms of timing, as precise as this one, that basically makes the job. And in this video, I will share with you all the different steps that I make to build a layout using Excel. So put yourself in my shoes. A retail company in China contacted me because they wanted to move to a new warehouse location. So I have visited their current warehouse. I know exactly how many racks they have, how many pallets on the ground they have, how the different areas are organized. And they told me, look, we found this new warehouse that is a bit closer to our customers, cheaper, but we want to make sure that everything fits in. So what you have on hand is a 2D plan like this, where you have all the different dimensions, all the different areas of the warehouse. So they tell you you can take this cell. So this cell is available. And you look at some details like here, you have an office, which means it's an area that you cannot use to store pallets. Here you have another office. Here you have the MEP equipment room. So MEP, I think it's the material handling tool, something like this. You have the property center. And here, I guess these are walls. Sometimes you have pillars and you have all the dimensions. And the role of the engineer here is to make sure that everything that is in the former warehouse fits here. So what are the next steps? Let's go on Excel. So now that we are on Excel, let me show you the first and probably the most important step to do. So the real estate company will give you this layout, right? I just cut the cell that we are going to work on. But what you have to understand is these real estate companies are not logistic professionals. So you cannot trust them in having all the dimensions needed for you to be able to design the layout inside the operational area. And this is a very good example here. As you could see, I added some information. So 1, 2, and 3, I think, is the different cells inside, sub-cells, as you can say, inside the building. And I think one is dry, another one is chill, another one is frozen. Here, what I called WOP, I think it's W is for weeds, and OP is like operational. Why is operational? Because that's the whole weeds where you can put pallets. Because here, as you could see, there is an office, equipment room, and property center. So you cannot put pallets on here. One of the most important things, as you can see here, is everything here in yellow. So as I told you, you cannot trust them to have all the dimensions. Most of the time you need to visit. And one thing that I discovered before visiting is there is not the dimension here of the width of this area, which is extremely important because I know how big this subcell is, but I don't know how much space I have for the pallets. And don't trust the scale effect because for most of the time it's just aesthetics. So I had to go there, ask them, then measure myself to add this information that here is 10 meters. I did the same here as 12.2 meters. And I trust myself of the past. I think it was 7 years ago, this project, that with all this information, we can exactly size the building. So now that you are confident after you visited the site, you can go back to your office and start building the layout. So this is exactly what I did here. It looks a bit messy, but don't worry. Everything is under control. I will explain you what I did. So as you can see, there are some grids. The idea here, this is my secret recipe, is to divide the whole operational space into rectangles or squares that have the same size. Why? Because I want to use these squares or rectangles to represent the potential future pallet location. As I told you, this is a warehouse. In a warehouse, you have racks, and inside racks, you have pallets. So each rack is a set of pallet location on the ground, and here we don't care about the height. So what we want to know is how much space we have to put the racks. So for that, you have width and length. And here I have chosen to divide the space in rectangles that have 1 meter length and 1.4 meter width. And I think if you sum up everything here, you have 11.2 meters, which is a bit higher than 10 meters. Why? Because what we want to do is to have some buffers. And it's exactly what I did here. I have created some buffers. So here we know we have the total space. We have the space of the offices with a bit of buffer. And you always want to take the buffer up. So you want to minimize a bit the space, because what happens for most of the time is you have surprises. So maybe you missed a dimension, maybe you missed a pillar. So you will probably be able to put less pallet than what you expected. So before validating a layout, usually I give myself a bit of a buffer to make sure that that we are covered if we validate the location. And then you put some calculation here to calculate the space available. So here, I think is the number of square meter. So it's multiplying 92. So 92 here is the total length. 60.2 is the total width. So here is the number of square meter available in this cell. This is the same here, and this is the same here. So I think I did that at that time to make sure that it matched with what they provided us, but I don't know if they shared here the square meters, probably not. Anyhow, we have here the total area that you can compare with what the real estate broker gives you. Here, number of cells, I don't understand. Yeah, I think here the total is a cell. The number of pallet location. So here's the number of pallet location that we need to fit on the ground. And here's the total storage locations. So this is just an idea for me to know how many pallets I need to fit in this location. And yeah, here, these are the parameters that I've been using to define the length and the width. So here, if I go here, it is pointing to length slot. And if you go here, it's pointing to width slot. Okay, well, I have mixed the names, but anyhow. So one is on x-axis, one is on y-axis. So the length spot, let me zoom a bit here so you can understand. The length slot is the length of the pallet. So sorry, here is length. I have put it in French. Plus a safety buffer. Why? So imagine that you have the racks that I showed you in the 3D layout. So you have the length, the width, and you want to know how much square meter you take. So you take the dimension of the pallets and then you put a bit of buffer because the rack will take a bit more than what the pallets have. Here, the safety buffer was 20 centimeters. For the width, so here we are talking about 120, 80 pallets. We take the width, we have the safety factor, and we have 1 meter. And this is where the, I would say, individual area is coming from. So you can be more aggressive and put a safety factor of 15 centimeters, but this was in accordance with the operation manager to take this approximation. So now that you did that, the layout that is without the pallets is ready to be used, and you can then test multiple setup of pallets, and this is what I'm going to show you later. Great, so now we can play Lego trying to fit all the different pallets inside our location. So as you could see here now, the layout is a bit richer, right? We have more items. One thing that I want to show you is that at that time, when I was trying to test multiple scenarios, I played a bit with the parameters that I've shown you before. So for instance, here, I think in the width, I have added an additional buffer for the racks. So here, I added the buffer for the pallet, depending on the pallet size, but I needed also to add some space because of the additional length of the racks. So it was, I think, at that time 1, and now it's 113. And this is, I think, what we see here. So let's look at more in details on the different change that I made. So here it was 1, now it's 113. Here, I have adapted the width because now I am putting racks, right? So this is a complete row of racks. These are 2 rows that are stuck. And here, this is the space between both. Normally, the space between both should be 3 meters. This is what I did here, but what you can see is 3.1. Why? Probably because if I want to fit it in the subcell, I needed to add a bit of buffer. You know, this is how you have to play with the different dimensions to have something that is a bit coherent. Here, it's like I showed, it's like the alley between both. I have put 1s on each pallet location. Why? Because if you do this, you can check here, you can count the number of pallets. So for instance, in the ambient cell, which is the first one, we have 1,343 pallets. No, I have counted too much. 1,085 pallets. And this is probably what the customer needs. I did the same for the second cell and for the third. As you could see here, I have fit the racks with comfortable space between them, operational areas. Here is a special process for fruits and vegetables, a kind of a cross-docking. W and C, I think wine and champagne, something like that, I forgot. And here we have the chilled area. So what is important here is we still have the same figures here. So when you play with the width and the length, you need to make sure that you are still fitting inside the building. And this is what we did here. So this is why probably here sometimes you have 1.1. You know, it's a way to adjust. And here we have the same length, and here we have the same width. So I think it's one of the scenarios that I did. I proposed multiple scenarios, I think, at that time. And then you can calculate some data for the decision makers. So you remind the different hypotheses you took, the dimension of the different cells, where you can also explain the buffer area that you have added, and then the number of pallets that you can fit per temperature control. So Everything remains on Excel. You can go from one scenario to another very easily because you have the checkpoints. And you can do that in less than half a day, unlike the SketchUp that would require more time. So that's roughly was the complete process of building this. The idea is not to have a final layout. It's just to make sure that we can fit all the pallets and the operational area in the location. Sometimes you need a couple of days for the decision making. Then when we validate the layout, I can do something a bit more precise, either on AutoCAD or using SketchUp. If you have any question about the methodology on how I did, the problem I faced, if you probably have some comments where I can do things a bit better, don't hesitate to use the comment section. I didn't use AI. Generative AI didn't exist at that time. And I'm quite convinced that generative AI will not help you here. So this is a kind of a video that I want to do now where we come back to the more traditional processes that we were doing in the past that are also efficient and more robust than asking an LLM to do this. See you for the next tutorial.